The last section is section 6, Galaxies and the Expanding Universe. Explain how the expansion of the universe made possible the formation of light nuclei and atoms. In the syllabus it says, students should appreciate that the very high temperatures at the early universe, only elementary fundamental particles could exist. In other words, quarks, leptons, which means up and down quarks, leptons, electrons and neutrinos and so on. The temperature was so high these particles would not come together, they would not form nuclei, they would not form protons and neutrons. The energy was too much. You had this particle soup that was so energized it wasn't able to condense to form protons and neutrons. Now eventually, as the universe expanded, the temperature went down as well. And as this happened, then this soup of particles were able to condense into matter that we recognize, like neutrons and protons and so on. So therefore we could form light nuclei, and then the protons and neutrons joined together to make helium, for example. So hydrogen was formed and helium was formed. And then the temperature was high enough still to create lots of hydrogen and lots of helium. But soon the temperature of the universe cooled so much that not many other elements were formed because the temperature had gone down so much. So there was an abundance of helium, there was an abundance of hydrogen, because the helium was able to be formed because the temperatures were so high. But as soon as the universe cooled down so much, the temperature wasn't high enough for fusion to take place. That's why we have so much hydrogen and helium in the universe. And this is a graphic which shows the age of the universe. We have these fantastically high temperatures to start with. We have this soup of quarks and particles and antiparticles and so on. And then we're able, as it cooled, it was able to form protons and neutrons. And then in this, after 1 second, between 1 second and 3 minutes, we're able to form hydrogen and helium nuclei, because it was cool enough for these elements to form. But then after that, it was too cold for other elements to form. So from the Big Bang, in the first 3 minutes, we formed all the hydrogen and helium there pretty much was going to be in the universe. The reason we have heavier elements now is because this nuclear fusion has happened in stars, but then it's cooler than this temperature. So helium and hydrogen are here, and then we're able to form balls of hydrogen gas and helium gas. They clump together and they produce stars. That's after 1 billion years. But it's pretty cool there. But when you have these balls of gas and you have this nuclear fusion, then you're able to form these heavier elements. And this is where we are today. We're at temperature of 3 Kelvin, which is pretty cold. You need to know pretty much these different part times of the Big Bang. In the first 10 to the negative 43 seconds, you just had these fundamental interactions, and we had this soup of fantastic and amazing particles. Then these forces started to separate. What's interesting is that between 10 to the negative 35 and 10 to the negative 24, there was a lot of matter and antimatter, but they were so energized that they're able to exist at the same time. Eventually, when it started to cool down during the so-called inflationary period, the matter outnumbered the antimatter, and there was a lot of annihilation, and what was left was the matter. After that, okay, at 10 to the negative 6 seconds, the temperature had dropped enough for individual protons and neutrons to exist. At around 2 seconds, neutrinos ceased to interact with protons and neutrons, and then you're able to form atoms. Protons and neutrons form together with electrons to make atoms of hydrogen and helium. By 3 minutes, by the time 3 minutes were over, after the Big Bang, all the hydrogen and the helium nuclei had been produced. So the way the universe is today really happened in the first 3 minutes. After that, then there was a massive expansion, and then eventually these big dust clouds managed to coalesce and form stars, but pretty much all the material was made in the first 3 minutes. After 300,000 years, the universe temperature had cooled enough to for these atoms to exist as atoms and not ions, and therefore, and light was able to pass between those. They were not absorbed so much now because we didn't have ionized universe. And this is basically when the 3 Kelvin radiation was emitted. Here's a graphic showing what happened. The most important thing is what happens in this stage here. Helium and hydrogen are formed after 1 to 10 to the 20 10 to the 2 seconds, and we are here now. And here we have the Big Bang again. But it's not going to happen again. It happened once. The universe is going to expand and die.